Hi, and welcome to section 4.3, the Simplex Method. This is the section of all sections. I am chuckling, but not in a good way. It is really a doozy, and this for sure will be the longest video of the quarter. And let me tell you about it. I've split it up into three parts. Part one is setting up a simplex matrix. That alone is tricky. Part two, reading off the solutions. How do you know when you're done? And I'm not being funny. Sometimes students go, they don't realize that they're done with the simplex matrix. So we'll talk about reading off the solutions, and then part three is actually solving a simplex matrix. And you guys ready for this? All right. Am I ready for this? Sure, why not? All right, so let's go ahead and start. I realized that's part three. Let's start with part one. So what is the simplex matrix all about? Okay, in real life, you've got money constraints, time constraints, labor constraints, maybe space. Maybe your factory is only so big. So how do you know how many products you can produce? How do you know what then your maximum profit can be? It's not a simple straight up answer when you consider all the constraints that you have. The simplex method is one of the ways you can take these constraints into consideration when looking at your profit, your revenue, your costs, and that type of thing. So where do you start? Well, where we start is we start with the function that we're asked to maximize. So that you'll be given a function that looks something like that, and that's a z. And you will also be given constraints. You will be given constraints, and it will look something like this over here on the left side. So the first thing to do is to rewrite f. So we're going to rewrite f. So the first step is to rewrite f, and so that it looks like the following. You want it to rewrite f as f minus 3x minus 5y minus 11z is equal to 0. Okay, so we want to do that first. So that's our first step. Our second step, okay, is identify the number of slack variables. Identify the number of slack variables. Okay, what that slack means, for example, up here, money, time, space, labor would be each considered a slack variable because they're putting constraints on your function, on your maximum. So in this particular problem, all right, so you're given this function that you want to maximize, and these here are your constraints. So how many constraints do you have? 3. So your number of slack variables is equal to your number of equations. All right, so we have S1, slack 2, and slack 3. So we have 3 slack variables that we are going to be putting into our function. S1, S2, and S3. Okay, so we rewrote f. First thing we did, we identified the number of slack variables. We have 3 of them. And then you write the coefficients. So you enter your coefficients only. So we're not going to put x, y, z. So enter your coefficients, and let's see, your slack variables, and using ones and zeros as fillers. Okay, let me show you what that means. We are not going to have room on this page, so I'm going to grab that. We're going to bring it over to the next page. Okay, and does everybody remember what f was? Let's see, at this point we had f minus 3x minus 5y minus 11z is equal to 0, and we knew that we had S1, S2, and S3. Okay, now watch what I do. Here we go. We're going to set this up using our coefficients and zeros and ones. All right, so across here, I'm going to put all my x values. Excuse me, down here, I'm going to put all my x values. So I've got a 2, a 1, and a 5. In this column, all my y values. 3, 4, 1. Next column, all my z values. 4, 1, 1. First slack value, 1, 0, 0. Second slack value, 0, 1, 0. Third slack value, 0, 0, 1. This is my function. You're going to fill that with zeros. I'll show you why. And here is what our constraints were. So we put 60, 48, and 48. Okay, so these are our constraints. All right, we're not done yet. Put a little dash line down here. Dash line going across. And a dash line going down this way. And I'm going to close this up. And let me show you what we're going to fill on the bottom. Okay, under x, we're going to put a -3. We got that from right up here. Okay, so that goes in the x column. This we're going to put in the y column, -5, and then -11. We're going to fill this with a 0, a 0, a 0, and a 1, and then another 0. Okay, let's take a look at it. And now we're done with the setup, but let me take a look. All right, so here's all of our x values, all of them. 2, a 1, and a 5. Got them all. And then we added that -3 on the bottom underneath the dash line. Here's all of our y values, 3, 4, 1, and then we added that -5. All of our z values, 4, 1, 1, and then we added the -11. Our first slack value, S1, notice it's 1 followed by all zeros. S2, 0, 1, 0, 0. S3, 0, 0, 1, 0, and your f function, 0, 0, 0, 1. You will always have this pattern, this diagonal pattern right there, always, with the rest filled by zeros. Okay, so you will have zeros everywhere else. So here are your coefficients, right, that we read off from our given constraints and our function that we're supposed to maximize. With regards to our slack variable and our function, we wrote 1's going diagonal, zeros everywhere else. And of course, don't forget your last column right there. Okay, let's do another one. Let's do one more setup. Make sure you got this down. All right, so example 2. This time you are supposed to maximize 4x plus 3y, subject to x plus 2y is less than or equal to 8. 2x plus y is less than or equal to 10. All right, you guys, first thing, what do? First thing is you rewrite this. So this is going to be f minus 4x minus 3y is equal to 0. Next thing, identify how many slackers you have. 2. S1, S2. How do you know that? You've got two equations. So you've got 2 slacks. All right, so now we're going to set it up. We have our x, and that's going to be a 1, a 2, and a -4. Our y's, a 2, a 1, and a -3. Do I have any z's? No, not in this one. So no z. So I'm going to go right into S1 with a 1 and a 0 and a 0. Then I'm going to go on to S2, which is going to be a 0, a 1, and a 0. Going on to F, which is always 0, 0, and then the last would be a 1. And then what are our constraints? 8, 10, and 0. That deserves a dash line, and this also gets a dash line going across there. And there is your setup. All right, so you see how you got that? You got all your x's, all your y's. You got 2 slacks in this case because you only had 2 equations. And then you see that those beautiful diagonal, right? Always have that nice diagonal there filled with zeros all around it. Okay, so I hope that helps with the setup of it. Now let's look at part 2, which is how do you know when you're done? So this is part 2, reading off solutions. And I am going to type this up. So pardon any typos because I will be trying to type as I talk. Okay, so how do you know when you're done? How do you know when you're done? And what are the solutions? Okay, first, you are done when all the values in the bottom row are positive. Okay, so that's how you know you're done. When looking at the solutions, only consider the columns with ones and zeros. The other columns are considered non-basic and are irrelevant. All right. To read the solution for a variable, look for the 1 in the column and find its corresponding value. That one is kind of unclear. Will become more clear when I show you. And then number 4, all non-basic columns, their corresponding variables are equal to 0. All right, so let me give you some examples so you know what that means. All right, so here's example number 1. Let's do it in blue. Example 1. All right, so you've already set it up. You've already set up the problem. You've already solved the problem. The problem that what you are now asking is, am I done? And what are the solutions? All right, so you have already, and I'm kind of going backwards here, you have already solved the problem. So we have x, y, z, and then we have an S1, an S2, an S3, a function, and then we have a constraint. All right, so because we've solved it, we have a 1, 0, 0, 0. In our y column, we have a 3, a -1, a -2, and a 5. In our z column, we have a 0, a 0, a 1, and a 0. Our S1 column, we have a 0, 1, 0, 0. S2, we have 3/4, 1/2, -1/2, and 5/6. In S3, we have 2, a -1, a 10, and an 11. And our function, we have 0, 0, 0, 1. And for our constraints, we have 10, 11, 16, and 500. And let's put our dash lines in. Let's finish this up. Dash line here. And a dash line going across the bottom. All right. So how do I know you're done? Look at your look at your bottom row. Here's your bottom row. Are all the values positive? Are all of them positive? Yes. So this is done and is ready to read. I'm going to repeat that. It is done because you have no negative values in the bottom row. When you get to that step, you are done. Put your pencil down and look for your solutions. All right, step 2. Only consider the columns that have 1s and 0s. So we're going to look at this column, not this one. Okay, that one doesn't have 0s and 1s. It has other numbers. We're going to look at this one. We're going to look at this one when we read off our solutions. We're not going to look at that one. We're not going to look at that one. And of course, we're going to look at the function that we maximize. So we'll look at that one. Okay, so only consider the 1s and 0s. Now to read off the column, locate the 1, There it is. And then find its corresponding value. So its corresponding value is 10. So we would say x is equal to 10. All right. Go to the z. Here's your 1 down here. What's its corresponding value? 16. So z is equal to 16. Next one, slacker, right here. Slacker 1, S1. S1 is equal to, what's its corresponding value? 11. You see that right there? Yeah, it's right there. All right, well, what about the rest? What about Y, S2, and S3? And of course, what about F? All these ones here are all zeros. Okay, why? Because they became irrelevant or non-basic columns. This is what I mean by number 4 down here. Oops, number 4 down here. Non-basic columns, their variables are always equal to 0. Okay, and then when is the function, or what is the maximum of this function? It's 500. So that's what that means right there. So f is equal to 500. Okay, so there you go. I think I'm going to go right into part 3 and actually set it up. All right, and actually solve one. So there's how you read off your solutions. Moving on to part 3. All right, so in part 3, solving. This is definitely going to take 2 pages at least. All right, and the one that I was going to do, let me go grab it. Okay, so it is number 49 in your book. And we are talking about section 4.3. And they don't give you the functions. You have to figure out what the functions are. Standard Steel Company produces 2 products. They produce railroad car wheels and axles. Production requires smelting and machining. Department A, which is the smelting department, has 50 hours available per week. Department B has 43 hours of labor available per week. Manufacturing 1 axle requires 4 hours in Department A and 3 hours in Department B. Manufacturing 1 wheel requires 3 hours in Department A and 5 hours in Department B. The profits are 300 per axle and 300 per wheel. Boom, that's F. Love that. Okay, so let's first figure out what X and Y are. So let's call X the number of wheels and Y the number of axles. And we know that F is equal to 300X plus 300Y. All right, last sentence right there. So the first thing I'm going to do is rewrite that. F minus 300X minus 300Y is equal to 0. Hey, I've got my bottom row, right? Next up, I need to come up with these equations, or these functions here. What am I given? Department A has 50 hours per week. Department B has 43 total. And I need to write this down. Department A, Department B. Okay, so in Department A, it requires 3 hours for the wheel, so 3x, and how many? I'm looking at Department A, and 4 hours for the axles in Department B, and that is subject to how many hours a week for Department A? 50. Department B has, oh boy, where is Department B? Department B, 5 hours for the wheel. Okay, so that's 5 hours for the wheel. How many for the axles? Oh, come on, 3. There it is. So 5x plus 3y, and that is subject to a total of 43 hours per week. Oh, boy, we haven't even started the problem. All right, so I think we've got everything, though. We can now set up our, we can now set it up I'm going to use a different color because I'm going to end up dragging it to the next page. So we've got Department A, Department B. Across we have X, Y. We've got two slackers, S1, S2. We'll have our function, and then we'll have our constraints. So X is 3 and 5, and what is it down here? Negative 300. Y is 4 and 3 and negative 300. S1, 1, 0, 0. S2, 0, 1, 0. F would be 0, 0, 1. And our constraints are 50, 43, and 0. Let's close everything up. We have set this up. Now we need to solve it. Okay, so let's grab this and go to the next page. Yep, that's not going to help. All right, so let's grab it again. Come on. Oh, come on. A little bit more. Yeah, I'll just take it as is. Go to the next page. Okay, and let's finish this up in blue. So my constraints were, I lost those, 50, 43, and 0. Okay, step 1. And by the way, I will tell you that they do a good job in the book, I thought, explaining this. I thought they did a pretty darn good job considering how difficult this topic is. Steps. 1. Identify the pivot column. And this is the smallest number. In other words, it's the most negative number. It's in the bottom row. Always look in the bottom row. And if it's a tie, if there's a tie, use either. Doesn't matter. Okay, so we have a tie, right? We've got a negative 300 and a negative 300. So it doesn't matter which one we're going to use. And so I'm just going to go ahead and use Y. So I chose this as my pivot column right here. Right here. Okay, next, after that, come here. All right, so the next step, step 2, come on. Thank you. So step 2 is identify the pivot entry. Okay, to do this, divide each constraint, yeah, I'll use that word, each constraint, which is the last column, by its corresponding pivot column entry. All right. Okay, so find that, and then use the one that ends up with the smallest value. Okay, let me show you what I mean by that. So one of these, and what I mean by these, is somewhere in here, okay, is your pivot entry. I'll tell you, it's either the 4 or the 3. The negative 300 was used to find the pivot column, but now we have to choose between 4 and 3. The way you do that is you take this number and you divide it by 4. So 50 divided by 4 is what? What is that? 12.5. Okay, and then go 43 divided by 3. Okay, why 4? Because that was its corresponding value in that row. Why 3? Because 3 and 43 are in the same row. 43 divided by 3 is 14.33. So you compare 14.33 to 12.5. Okay, pick the one with the smallest, like the way I spell smallest. I spelled it totally wrong. Smallest value. So of these two, 12.5 and 14.33, the 4 is smaller. So this right here is my pivot entry. Okay, once you identify your pivot entry, multiply So once that's identified, once the pivot entry is found, divide the entire pivot row, not column, by this factor. All right, so we're going to end up having, so I'm going to divide this entire first row by 4. So this is going to be, come on brush, there we go. So this is going to be 3/4, a 1, a 1/4, a 0, a 0, and a 12.5. I haven't done anything to the rest, so I'm going to rewrite, or just write it as is. Let's see, 1, 0, 0, 1, 43, and 0. Okay, so I divided everything, so I got my 1. Now, my goal is, I need the numbers below my pivot. Okay, here's my pivot. I need this and this to be zeros. All right, so I need zeros below it and above it. In this case, it's just obviously going to be below it. So does this remind you of the Gauss-Jordan elimination? It should. So this needs to become a 0, and I need this to become a 0. In order to do that, I'm going to go -3 times row 1, and I'm going to add it to row 2. At the same time, I'm going to go 300 times row 1 and add it to row 3. My new values will look like this. Okay, this is not going to be affected. Not doing anything with that column. My 1, oh yes I am. Hello. There we go. Okay, sorry about that. Jumping ahead, aren't I? All right, so I've got my, I'm not doing anything with this row except for using it, but I'm not actually changing any of the values. I like what I see up there, as a matter of fact. Okay, now I'm going to go times -3. All right, so I'm going times -3 times that entire first row. So times -3, -3 times -3. So I'm going to get -3/4. This is going to be -9/4. -9/4 and 5. -9/4 and 5 is going to be 11/4. This is going to be a 0. -3/4 and 0. That's going to end up being still a 1. And then -3/4 times 12.5 added to 43. Oh, you guys grab your calculator. I did it ahead of time and I got 5.5. Okay, at the same time, I'm also going 300 times this number. So 300, that's going to give you 900/4. And -3, 900/4 minus 300, which is going to give you -75. This becomes a 0. This becomes a 75, a 0, a 1, and a 3,750. And let's take a look at what we have and see if we can stop yet. So, can we stop yet? How do you identify that? Well, you identify that. Hold on here. All right, so as you can see, I went ahead and brought that matrix over, and I was making the point that we are not done yet because you still have negative values in that bottom row, unfortunately. So we have to continue, and we repeat the process. So we are going to repeat everything that we did. And you remember the first step? It was to find the most negative value in the bottom row. Well, this time it's pretty obvious because it's the -75. It's the only negative number in your bottom row. Now we have to choose, is the 11/4 or the 3/4 or the 11/4 your pivot entry? So we are now looking for our pivot entry. All right, so which one is our pivot entry? To find that, you need to go 5.5 divided by 11/4. And when you grab your handy dandy calculator, you realize that's equal to 2. And then we need to compare it to 12.5 divided by 3/4. Grab your handy dandy calculator, and that's like 16.666 or 6. Let's make that a 7. All right, so it's obvious that this is the smaller value, and therefore 11/4 is your pivot entry. So right here is your pivot entry. So we need to make that a 1. So we take that entire row and we multiply it times 4/11. Take that entire row. So we're not doing anything to the first row. Let's see, 0, 0, 12.5. This row, dividing by 4/11, or excuse me, dividing by 11/4. Let's see, 3/11, right? 4/11, 0, and 5.5. I know that value is 2. I've already done that. And in the bottom row, 0, 1, 37.50. And I believe this is a 4 there. Okay, now we need to make everything above and below a 0. So we want this to be a 0 and this to be a 0. So we are going to take the first row, multiply it by -3/4, excuse me, the second row, and add it to the first row. So we're going to multiply this by -3/4 and then add it to the first row. At the same time, we're going to multiply the second row by 75 and add that to the third row, right? So we want this to be a 0. So if this was a 75, we could add it. Okay, so we're going to do those two things at the same time. Grab my purple again. Feeling purple today. All right, so what do we end up having? Oh, good. I did write these values down. So this ends up being on the top. This ends up being a 0. This, of course, is still a 1. Sorry for my hesitation here. And then times -3/4. And then you add that. I got 2/44 for that. I hope that's correct. And then this next one, I got a... Are we having fun yet? I got -3/11. This one is a 0. And for this one, I got an 11. This row hasn't changed. Did I tell you how awful this Simplex matrix is yet? Oh my gosh. I guess you just have to have a sense of humor, right? Or go grab a cup of coffee or something to make yourself feel better. All right, this is going to become a 0 because now we're timesing this by 75. That's going to stay a 0. 75 times 3/11 added to 75. Are you serious? Yeah, unfortunately I am. I got 54.54. I hope that's right. Over here I got 27.27. Over here that stayed a 1. And over here I got 3,900. And the way I did that is I multiplied that times 75 and I added it to the 3750. All right. How fun are we having? Are we done? Yes, hallelujah. How do we know that we're done? The entire bottom row is positive. All right, so now we can finally read off answers. So where are my 1s and 0s? Let's see. I've got a 1 here. So that means that y is equal to 11. What do I have here? An x. That's my other x, my other value. And that's equal to 2. Okay, what is my slacker 1 variable? 0. Slacker 2 variable is also 0. And when is this maximized? At 3,900. Okay, so this was my other value right there. My S1 and S2, interesting enough, ended up being non-basic columns. So the variables are zeros. Okay, so these are definitely long. Make yourself comfortable when you're doing them. And thanks for tuning in. I hope this helped. Bye.